and the impact of this starts from 1 decade before and it lasts up to 1 decade after. And it wants to have an impact of plus 45 degrees. So it wants to have something like this. Impact something like this. Plus 45 degree per decade, right? These two would cancel out each other. So like, then we would have a constant negative 45 degrees phase here, right? So the impact of this one, the impact of this pole is now finished at this point. So if we didn't have this pole, then we would have a plus 45 degree per decade rise here. But so what this zero wants to do, still wants to have a plus 45 degree per decade impact here. But this pole, it's gonna start its impact 1 decade before, and its impact it's gonna last up to 1 decade after. So what this pole wants to do, wants to basically do something like this, minus 45 degree per decade. Again, these two would cancel out each other. So up to 10, the phase is gonna stay constant. And now the residue of the impact of this pole, it's gonna last up to here. So we're gonna have a negative 45 degree per decade up to here, and it gets to negative 90. And 1 decade after the impact of the pole, it's gonna finish. So it's gonna stay at this. And you remember that we predicted that the phase at infinity, it should be negative 90. So which is the case, right? It goes from 0, then negative 45 degrees per decade, stays at negative 45 degrees up to here, goes down with the slope of negative 45 degrees per decade, and then stays at negative 90 degrees up from this point on. Right, so this is how you can draw a body plot. This is not very exact, but it can give you a good approximation, and it would basically show like how the magnitude and phase of a transfer function changes, or like how the magnitude and phase of a signal changes if you have its S domain format. Now I wanna like what I mentioned here, like the impact of poles and zeros on the gain. We want to see like why this is the case. Just like I don't want to get into the details, but let's just like do a very quick example, very small example that would tell us like why we have this much these kind of impacts from having a pole or like a zero. So for a very simple transfer function like this, g of s is equal to s, right? And you remember s is equal to j omega, right? So it means that if I look at the magnitude of g and phase of g, right? If omega is equal to one, s is gonna be j1, right? What's the magnitude? Magnitude is 1. What's the phase? The phase is gonna be 90 degrees. Because j1, if you look at it, it's gonna be right here, right? The phase is 90 degrees, right? If omega is 10, magnitude, it's gonna be j10, right? Sorry, G of S is J10. Magnitude, it's gonna be 20 log, I made a mistake here. This is 1 or 0 dB. Okay, let's just like do it in dB. So it's gonna be 0. 20 log of 10, it's gonna be, this is gonna be 1, so it's gonna be 20, right? What about the phase? It's still gonna be 90 degrees. J100, this becomes 40. This is still 90. J1000, this becomes 60. This is still 90. Omega equal to 0.1, J 0.1. This is going to be 20 log of 0.1. This is negative 1, right? So it's going to be negative 20. But phase is still 90 degrees. So this shows the impact of zeros, right? That's where this 20 dB per decade comes from. You can see that from the point that we have the zero, we're gonna have a 20 dB per decade increase in our gain. The same thing applies if you do G of S equal to 1 over S. You can see simply like exactly the opposite thing is gonna happen. You're gonna have a negative dB per decade impact because of that pole. So that's just like to show you roughly why we have these things here. Okay. The next concept, which is a little bit challenging, it is in your lecture, so I have to mention it. We don't need to do a very thorough analysis, but we have to be familiar with it, so it's gonna be important for me to mention this. This is the concept of root locus, which is a very useful tool to find the closed loop stability. Okay, so you guys remember that we mentioned that our closed loop system looks something like this. Okay, this is Y, this is Y ref, this is E, this is U, right? So far we focused only on our main system, which is our plant, right? So you look at the poles and zeros of this one, we figure out if this is going to be stable or not stable. But once you add the feedback, once you add the controller, the sensor, like this error, everything, now we have a bigger system. This is